Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. We have created this special Top 10 series to highlight the most compelling evidences for the dominant role of electromagnetism at all scales throughout the cosmos. Thanks to ever finer technological data, the existence of electric currents traveling through space is now undeniable, and is more and more routinely acknowledged by astronomers and astrophysicists. Yet the ramifications of this revelation have been slow in affecting any meaningful change in consensus scientific theory. A major obstacle is a lingering belief that science discovery has emphatically contradicted, that celestial objects cannot have any net charge separation. It is then not a coincidence that objects in space behaving like charged bodies, from the mysterious collimated jets of comets, to the spectacular sprites and elves seen on our own planet's upper atmosphere, to the catastrophic electrical discharges focused on stars producing supernova explosions, to extragalactic jets traveling at nearly the speed of light over 1 million light-years or more. Today, we will explore why the high-energy electrical scarring of bodies in our solar system is the 8th of 10 reasons why the universe is electric. The electrical scarring of planets and moons. The myth of a solar system that has remained unchanged since its hypothetical formation 4.5 billion years ago has now crumbled. As we've reported in many episodes in recent years, the standard theory of planets and stars forming in a nebular cloud from gravitational collapse and accretion finds no support in the thousands of exoplanetary systems discovered to date. As astronomer Gregory Laughlin told the journal Nature in 2014, using our solar system as a model has, quote, led to no success in extrapolating what's out there. So different as our solar system seemed to be that astronomers now increasingly entertain the notion of planetary migration. As noted in a recent phys.org report, in our solar system, the inner planets have surprisingly large spacing and diverse sizes. Abundant evidence in the solar system suggests that Jupiter and Saturn disrupted our system's early structure, resulting in the 4 widely spaced terrestrial planets we have today. Some astronomers today now suggest that these gas giants acted as so-called wrecking balls, migrating toward the inner solar system, destroying an early generation of planets and robbing the planet Mars of its lighter elements. The gas giants may have indeed acted as, quote, wrecking balls, though not through mechanical collisions and tidal forces, but rather through bodies of different potentials discharging electrically. As we will see, the experimentally proven ability of high-energy electrical discharges to produce craters and countless other planetary features offers an entirely new perspective on planetary science and the solar system's history. The Moon. The most heavily studied rocky body in the solar system outside of the Earth is, of course, the Moon. When the first space probes returned images of the Moon, they revealed a surface heavily pockmarked with craters and riddled with long sinuous channels, called rills. Scientists seeking to interpret these features were constrained by the traditional geologic toolkit. The, quote, debate over the lunar craters only included 2 possible causative agents: volcanism or impact. Eventually, a consensus was reached that meteoritic impacts were the primary source of lunar craters. The Moon and some other bodies in the solar system are so heavily cratered that astronomers invented a violent epoch called the Late Heavy Bombardment, a hypothetical period when disproportionate numbers of asteroids supposedly collided with planets in the inner solar system. One reason for the hypothesis is that isotopic dating of moon rocks seems to imply that the so-called impacts that caused rocks to melt appear to have happened over a relatively short period of time. But like countless other discoveries, the simultaneous appearance of many lunar craters is consistent with the electric discharge hypothesis. Far from popular consideration, well before the first man walked on the Moon, the amateur astronomer Brian J. Ford published his laboratory experiments suggesting that craters on the Moon were carved by cosmic lightning bolts. In the cited experiments, Ford used a spark machining apparatus to reproduce in miniature some of the most puzzling lunar features, including craters with central peaks, small craters preferentially perched on the high rims of larger craters, and craters strung out in long chains. Ford also observed that the ratio of large to small craters on the Moon matched the ratio seen in electrical arcing. The craters we observe on the Moon emphasize the need for radically new theoretical pathways in planetary science. One mystery that the impact hypothesis will never explain is the extreme circularity of the vast majority of lunar craters. Experiments with impacts have long shown that in order to produce a highly circular crater, an object typically must strike the surface from directly above. The aforementioned Brian Ford noted that over 90% of circular craters on the Moon could not have been produced by sideswiping impacts. As on other rocky bodies, we see countless cleanly cut craters with no ejecta on the crater floors. Electrical engineer Ralph Jurgens, an early proponent of electrical planetary scarring, wrote of this phenomenon. Explaining a crater floor of bare, once molten rock in terms of the conventional impact theory is a little difficult. One must resort to ad hoc theorizing to the effect that something, perhaps the shock of the postulated impact explosion, melted a considerable volume of rock at some depth, and that following the explosion, this material welled up to engulf the crater floor and flow around obstructions encountered there. Otherwise, debris from the explosion itself could be expected to clutter the crater floor. Impact theory offers no reason, however, to expect such a sequence of events, and nothing in terrestrial experience with crater-producing explosions supports the idea. Though an electric discharge might be thought of as taking place in a very brief span of time, an interplanetary discharge must surely be an event of greater duration than an impact explosion. The long-distance flow of current would persist beyond the instant of any initial touchdown explosion, and ejecta that chanced to fall back into the crater thus produced could be swept away or melted in place. Jurgens also published a groundbreaking analysis of the sinuous rills on the lunar surface. A sinuous rill is a long, winding valley, usually with steep walls and often emerging from a crater, which can be found on the Moon at many scales. Prior to the Apollo missions, astronomers' early hypotheses suggested that the rills were, quote, cracks on the Moon's surface. Later guesses included flowing water, until scientists settled on flowing lava as the agent. Today, the accepted theory is that the Moon's sinuous rills were created either by lava flowing across the surface or beneath the ground to form a, quote, lava tube, portions of which eventually collapsed. Jurgens compared the respective point-by-point requirements of various competing theories versus the actual observed characteristics of the rills. Unlike planetary scientists, Jurgens included among the possible agents high-energy electrical discharge. On every evidentiary point, the electrical discharge hypothesis is either permissible or predictable. And unlike every competing hypothesis, in not a single instance does the evidence preclude electrical discharge as the cause of the rills. Even prior to Jurgens' investigation, several scientists had noted that flowing liquids, whether water or lava, could not have caused the observed features of the lunar rills, including the strings of craters along the rills' floors. These points are dramatically emphasized when we examine the Moon's famous Hadley Rill. Today, planetary scientists agree that the rill is a, quote, collapsed lava tube. However, the rill does not match the required characteristics of lava tubes on numerous points. Most importantly, the collapsed areas of a lava tube will be rubble-filled depressions. High-resolution images of the rill reveal no rubble and no collapsed tubes. It is simply an empty, sharply cut channel, which matches the expected characteristics of a, quote, electrical breakdown channel. Perhaps the greatest problem for the volcanic hypothesis of lunar rills is their tremendous length. On our own planet, the longest lava tube reaches only 65 kilometers. That is about half the length of Hadley Rill, which is 130 kilometers. However, the exact opposite should be true. On Earth, the atmosphere is insulating, allowing lava to retain its heat. In the, quote, vacuum of space, heat will be much more rapidly radiated away. On our own planet, as lava flows over distances no more than tens of kilometers, the cooling at the surface causes a, quote, roof to form. It may then continue to flow as a tube beneath the surface. That is the only way the lava tubes can achieve even their modest lengths. Consider then the most prominent lunar rill, called Schroeder's Valley, 185 kilometers long and up to 10 kilometers wide, with its depth at points reaching up to 1,300 meters. Flowing lava eating away surface material to cut a deep channel would have to show up somewhere. We should see either breaches in the deep walls, or evidence of abundant outflow. Instead, the channel simply dwindles until it disappears. Curiously, the flow of rills on the moon and other worlds isn't limited to downhill, like lava and water-carved channels on Earth. All fluid erosion theories for Schroeder's Valley have chosen to ignore that the apparent mouth of the quote stream is on high ground, and the narrowest part of the channel is on low ground. We also note that within Schroeder's Valley is a much more narrow, secondary rill whose defining feature is a chain of small craters. As we turn our attention from the moon to the planets in the inner solar system, we will see emphatically demonstrated the failures of standard geological theory to explain the most dramatic features on planetary surfaces. Venus. Many years before the first space probe returned images of the surface of the planet Venus, one of the 20th century's great scientific heretics, Immanuel Velikovsky, made several outrageous claims about Venus. Velikovsky proposed that just a few thousand years ago, Venus appeared in the earthly sky as a terrifying comet. In stark contrast, many astronomers, including the originator of the dirty snowball hypothesis of comets, Fred Whipple, had proposed that the surface of Venus might be mostly or entirely covered with oceans. So the discovery of Venus's super-hot temperatures, an average surface temperature of 863 degrees Fahrenheit, was one of the great surprises of the early space age. Another surprise is the amazingly, quote, young appearance of Venus's surface. Venus shows an astonishing lack of so-called impact craters, which most planetary scientists today believe is due to a, quote, resurfacing process that must have removed the craters. Most likely a recent volcanic overturning of the entire Venusian crust. The most striking features on Venus are the vast networks of filamentary scars, or what experimentalists with electrical discharge recognize as, quote, Lichtenberg patterns. In the electric universe theory, some rocky planets are born in the same glowing electric filaments as stars, which are seen strung like beads on a necklace in molecular clouds. Others are born by electrical fissioning of larger bodies in the process of adjusting to a suddenly changing electrical environment. If Venus was once an Earth-threatening comet, as ancient testimony from around the world universally claims, it must have had an eccentric orbit that brought it close to the Earth. Electrical discharging would have heated the crust and created the filamentary scars stretching across the planet's surface. Of course, it has long been shown experimentally that lightning occurring in a high-pressure gas causes this kind of, quote, Lichtenberg pattern. At low atmospheric pressures, cratering is more common, as seen on the Moon and the planet Mercury. Intriguingly, in 2013, science reports described the Venusian ionosphere's interactions with the solar wind as being more typical of a comet than a planet. And like a comet, Venus has a vast tail that stretches up to millions of kilometers, sometimes touching the Earth's magnetosphere. The planet's super-hot temperatures, its mysterious superrotation, and its extraordinarily powerful lightning are all expected in the electric universe reconstruction of Venus's recent cometary origins. As we continue, we will see overwhelming evidence for the cataclysmic events, the thunderbolts of the gods, that ravaged the planets in the inner solar system. Mars. Prior to the space age, most astronomers had expected Mars to be a long geologically dead and barren rock in space. But beginning with the arrival of the first space probes, the surface features of the red planet have provided endless surprises for planetary scientists. Mars today is a world with spectacular weather events, including tremendous wind and dust storms that sometimes engulf the entire planet. But nothing we observe today accounts for the remarkable and often bizarre Martian geology. including features that speak to events more violent than anything that has ever occurred on our own planet. The most dramatic features on Mars provide all of the clues to these events. The stupendous Valles Marineris is a chasm that stretches for 4,000 kilometers long and up to 7 kilometers in depth. For comparison, even though Mars is only about half the size of Earth, Valles Marineris is the length of about 5 Grand Canyons. It was the aforementioned Ralph Jurgens who proposed in the 1970s that Valles Marineris was a vast scar carved by an interplanetary lightning bolt. In fact, as we reported in a 2015 Space News, the hypothesis of the electrical origin of Valles Marineris has been tested experimentally. In a collaboration between the late Michael Steinbacher and engineer Billy Elverton, the experiment attempted to simulate the conditions that might have been present when the trench was formed, with dust being dropped from a reservoir above a discharge table, as seen on your screen. The feature that consistently appeared greatly resembled Valles Marineris. The two also noticed a pattern that physicist Wal Thornhill had previously noted in a 2003 article entitled Spiral Galaxies and Grand Canyons. Valles Marineris' S-shape, reproduced in the electrical discharge experiments, strongly resembles the form of a barred spiral galaxy. As Thornhill wrote in 2003, the connection lies in the fact that galaxies are the largest visible electric discharge phenomenon in the universe. Of course, as we've detailed many times, this notion has extraordinary experimental support, as demonstrated in the images on your screen of the plasma experiments by Dr. Anthony Peratt and Winston Bostick, respectively. In the feature-length documentary film, The Lightning-Scarred Planet Mars, detailed analysis was offered of countless Martian features that find ideal analogs in electrical discharge. One such example is the towering Olympus Mons, a nearly 22-kilometer-high so-called shield volcano, and the tallest mountain of any planet in the solar system. As noted in the film, the shield volcano interpretation of Olympus Mons presents far more enigmas than answers. The defining feature of any shield volcano is a gentle extrusion of fluid, or low-viscosity lava. Shield volcanoes on Earth do not present a scarp, whereas the scarp of Olympus Mons towers at nearly 4 miles high. A NASA report acknowledges this problem as follows. The scarp is of unknown origins. The steep cliff around Olympus Mons is peculiar and not characteristic of terrestrial shield volcanoes. But perhaps most significant of all is the blanket of incredibly fine filamentary ridges and ravines within the terrain of Olympus Mons. In fact, the continued discovery of perplexing dendritic patterns on Mars is a key prediction of the electrical scarring hypothesis. A pristine example was discovered in 2017, when an image was released of the terrain within the 10-kilometer Zunil crater on Mars. Planetary scientists insist that the crater was produced by an impact. They have no real explanation for the raised dendritic features associated with secondary craters within the crater. NASA's attempt to explain the image reads as follows. Secondary craters form from rocks ejected at high speed from the primary crater, which then impact the ground at sufficiently high speed to make huge numbers of much smaller craters over a large region. In this scene, however, the secondary crater ejecta has an unusual raised relief appearance, like bas-relief sculpture. The best guess NASA can offer is that the so-called impact crater has been mysteriously weathered over eons of time. But experimental research within the EU community provides much more promising possibilities. One such experiment, performed by the aforementioned Billy Elverton, produced raised dendritic ridges simply by applying intense vibrations to soil. Consider also this experiment performed by YouTube user DieFlyFish, subjecting aluminum foil to electrical discharge. And consider also this side-by-side comparison of highly mysterious so-called Martian spiders and an electrical discharge experiment performed by Zane Parker. As we've said before, the Martian environment is a, quote, laboratory in space for testing the concepts of electric universe geology. As we've detailed many times, more than a decade ago, Dr. C.J. Ransom performed the only experiments to date that have reproduced the Martian blueberries, tiny spherules that appear by the trillions embedded in the Martian soil. And the same spherical forms are seen in giant, mysterious domes inside of craters, a continuing puzzle for planetary scientists. A great testimony to the electrical catastrophes that ravaged Mars is the more than 6 miles of crustal depth, which was mysteriously removed from the Martian northern hemisphere. Where did all this material go? A clue is found in the completely unexpected discovery of Martian meteorites on Earth. Initially, planetary scientists treated the discovery with great skepticism, since they did not expect that the escaped material could reach the necessary velocities to bring it to Earth. The massive electrical excavation of Mars could have also been the source of the mysterious asteroids that share Mars's orbit, called Trojans. In fact, a scientific paper published in 2017 proposed that the asteroids are the remains of a decimated mini-planet, since they are composed of olivine and other distinctly planetary minerals. Planetary scientists also imagine violent collisions as the likely source of the Martian moons Phobos and Deimos. As described in a Space.com report, a large impactor smashing into the red planet could have sent pieces flying into the air, where gravity may have drawn them together. An existing moon might have also been destroyed, creating the rubble that later formed Phobos and Deimos. As we look closer at Mars's Phobos, collisions and gravitational accretion, the only theoretical mechanisms available for planetary scientists, prove totally inadequate to explain what we actually see. Like countless other rocky bodies, we see dramatic parallel channels and crater chains, features not expected at all from mechanical collisions. But as we've illustrated dozens of times, they are routinely produced in experiments with electrical discharge. And the most dramatic feature on Phobos, the astonishing Stickney crater, underscores a puzzle that is repeated on countless bodies in the solar system. The crater is 9 kilometers across, nearly half the diameter of Phobos itself. How could any impact capable of producing such a massive crater fail to shatter the moon? A similarly improbably huge crater is seen here on the Saturnian moon Tethys. The moon is only 1,000 kilometers in diameter, and yet its giant hexagonal crater is an incredible 450 kilometers across. As reported by UniverseToday.com, whatever struck Tethys in the distant past probably should have shattered it into pieces, but didn't. On the famous asteroid Vesta, the largest so-called impact crater is an astounding 475 kilometers across. The diameter of the asteroid is only 525 kilometers. Craters much too massive to have been produced by mechanical collisions is just one of many enigmas resolved by the electrical scarring hypothesis. In the companion piece to this video, called "The Craters Are Electric," we outlined numerous types of craters seen on every type of solid body that are routinely produced by electrical discharge in the laboratory, including weird hexagonal or square craters, so-called bullseye craters, craters with flat floors and pinched-up rims, the extreme circularity of craters, and the complete anomaly of smaller craters appearing on the rims of larger craters. If we apply these explanations to the massively cratered surfaces of airless worlds, as seen on our moon, on the planet Mercury, on the dwarf planet Ceres, and in the outer solar system on the respective moons of the gas giants, we find a simple resolution to endless mysteries that the impact hypothesis has never explained. As the electric universe geology community continues its inevitable growth, the closer humankind comes to a reconstruction of an essential chapter of our history. A chapter of a drama not written in science textbooks, yet indelibly imprinted in every arena of human culture. A drama waiting to be remembered.